Good morning once again, guys. Today we're going to begin our journey in learning about linear regression, both simple and multiple linear regression. This is a review of what you have discussed in your previous statistics subject. The only difference is that here you're going to learn it using R, while most probably, so let me just have your replies at chat box, guys. Did you learn your simple or multiple regression before in your previous subject using R, or yes or no na lang? Did you use R before? Kindly chat, please. Okay. Okay. Good. Good. As data. Okay. Some of you learned it through Stata. Some of you learned it through most probably Excel. Kaila John. At saka kay, sino pa ba yung isa? Who was the other one? Kay Angel, kay John, Stata. Anong subject yun? Pati si Mary, no? Could you please tell me, anong subject yung ginamit ang Stata? SOE classes. Okay, I suspected that. May statistika din and SAS. Mark, saan yung ginamit ng statistika and SAS? Gumamit kayo ng SAS? Oh, I see. Pati COS. Okay. All right. So, statistika, SAS, AB Psych as well. Okay, that's good, no? That's good. So, some of you know already how to navigate through the Stata software. Yung iba naman, statistika, yung iba SAS. These are very powerful statistical softwares, guys. So maganda, guys. Yung first course ko po, okay, shifting to, yan. Thank you. Thank you for your feedback, guys. Now, ang kagandahan yan, guys, pag nag-thesis na kayo, for example, you have at your fingertips, no? Yung paggamit ng mga softwares na to. So, karamihan ng mga nag-thesis, guys, in a few terms, aabot din kayo doon. Ito yung mga softwares na ginagamit nila. And a good software also to use is R. So we're going to use that now in learning simple and multiple regression. Okay, so this is the file I sent you, guys, Intro to Regression class. Now, there are some blanks here, some blanks. So I will require you to do the code. Pero ipapakita ko rin, in the interest of time, I didn't want, guys, that nakabigay na yung code nun kasi gusto ko yung nag-aan din kayo, naglalagay din kayo ng code, sa R markdown file natin. Okay, so this is just a quick review. Diba ang regression, guys? Two major types. You have simple linear regression and multiple linear regression. Anong difference ng simple linear regression at saka multiple linear regression? Anyone? What's the difference? Simple versus multiple. Can you recall, guys? Ano man difference sila? Let's start first with what a regression is. A regression, guys, is a statistical process where you try to infer or to determine whether there's a statistically significant relationship between your variables, your dependent variable and your independent variable. Your dependent variable, aka your outcome variable. There are many names for your dependent variable, and then in relation to your independent variables or your predictor variables. Okay, number of variables involved. Okay, I got here some answers. Number of variables involved according to Angel, ganun din kay Mark, kay Naoki, independent variables and dependent. So ano difference sila? Pag simple, guys, you have only one outcome variable, di ba? And you'd like to, of course, one dependent variable, dapat continuous yun. Parehong isa lang naman pala, I'm sorry, no? Isang dependent variable, isang outcome variable, And then, pag simple guys, you only have one predictor, one independent variable and one dependent variable. So that's what we call a simple linear regression. On the other hand, a multiple linear regression entails that you have one dependent variable, tapos dapat continuous yung variable na yun, and then you have several, two or more independent variables. So we'd like, in a regression model, we would like to determine if there's a statistical relationship between your dependent variable and your independent variable or independent variables, as the case may be. Okay, so when we talk about regression, we're not talking about causality. We're not saying that the independent variable causes the dependent variable. Okay, so take note of that. No, sa regression, hindi natin in-establish yung causality. Ang inaano lang natin yung relationship between them. When we say relationship, what we mean is, pag tumataas ba yung isa, if the value of one increases, does the value of the other one increases also? Or vice versa, or opposite ba? Kung tumataas yung isang value, bumababa ba yung isa? Okay, so that's what we mean. That's what we call negative relationship. Yung positive relationship naman, they move in the same direction. Pag tumataas yung isa, tumataas din yung isa. Pag bumababa yung isa, bumababa din yung isa. Okay? So sometimes we use the word cause, the independent variable causes the dependent variable. But the use of the word cause there is not the regular meaning of causality, no? Pag ginagamit mo yung word na causes, aka impacts, or is related to, so we just mean that there's an association between them, not really that the independent variable causes the dependent variable. So we just take note of that, no? So hindi causality yung ini-establish sa regression, but rather association or relationship. Okay, when we look at regression, guys, there are certain assumptions that are followed, no? So there are several assumptions. So these are the regression assumptions. And in regression, we use the OLS. I'm sure you have met this. What's OLS? Anyone? Have you met that acronym OLS? Kindly chat or unmute yourself, guys. Ano ibig sabihin ng OLS? Okay, thank you, Angel. That's correct. Ordinary least squares. Thank you. Thank you, Naoki. Thank you, RJ. Okay, that's very good. Okay, alam niyo yung method na ginagamit in coming up with a simple or multiple linear regression. We use what we call ordinary least squares. We're going to discuss this in greater detail as we go on. So there are several assumptions in a classic simple or multiple linear regression. Okay, number one, linearity of the data. What do we mean by linearity of the data? Dapat, guys, linearly associated or linearly related yung outcome variable natin, yung dependent variable natin, and your independent variable x. Dapat linear yung relationship nila. So that if we plot it, makikita natin na there is a linear plot, no? They approximate a linear plot. Why is this important? Kasi pag pinat natin, guys, yung x natin at saka y natin on a Cartesian coordinate system, and if the relationship seems to follow a quadratic form or a polynomial form, okay, then we cannot choose the OLS. Hindi tayo pwedeng mag-linear regression sa kanila kasi nababiolate kagad yung unang condition. Dapat linear relationship ng dependent natin at saka independent variable natin. Okay? So that means, guys, when we do regression, maganda kung ipa-plot muna natin sila. Okay? We plot the data to see if there is really a relationship, linear relationship between them, or may approximate na linear relationship between them. Tapos, we can also, what measure can we use, guys? Aside from plotting, we can also measure, what's a statistical measure that we can use in order to determine kung may linear relationship yung dalawa. Anyone? What did you learn in your prior subjects? Ano yung pwedeng i-measure natin para makita natin kung may linear relationship nga sila? Kindly chat please, or kindly unmute yourself. Basic metric, guys, to determine if two variables are linearly associated. Okay, let's see. All right, very good, no? Okay, thank you, Angel. Thank you, Naoki. You're correct. No? It's a correlation coefficient, yung Pearson correlation coefficient. Okay, we can measure the relationship between the two variables and see if there's a linear relationship between them. So if the relationship between them, if the correlation coefficient, for example, is very low, 0.02, 0.03, okay, then that means, guys, that there's practically no linear relationship between the two variables. Then most probably, guys, we will not be able to come up with a model in trying to establish the relationship between your dependent and independent variable. On the other hand, if the correlation between the two is very high, 0.8, 0.7, they're high, okay, then most probably we can establish or determine a linear regression model in trying to establish the relationship between your independent and dependent variable. Okay, the second assumption is that there should be linearity in the parameters. Okay, ano to? Ano yung linearity in the parameters? Okay, so siguro sulat ako dito. Diba, guys, if you recall, yung equation natin, y is equal to beta null plus beta 1 times x1 plus b2 times x2 plus b3 times x3, okay, plus a certain error term. No? Okay, so ito, guys, yung ito yung basic na regression equation natin. So your dependent variable y is a function of a certain constant, which is your intercept, plus b1, which is the slope for x1. This is the coefficient for x1. Yung x1 natin, x2, x3, they are our predictors. They are our independent variables. Okay, b1, b2, b3. Now, what do we mean by linearity in the parameters? Okay, ang ibig sabihin niyan, guys, yung mga b1, b2, b3, okay, they should be linear. In other words, hindi siya pwedeng naka-square root. Square root of b1. Hindi pwedeng b squared, b2 cubed. Okay, hindi pwedeng 1 over b3. Okay, hindi pwedeng ganon. Kailangan yung b1, b2, b3 natin, they should be linear. Okay, so hindi lang linear dapat yung relationship ng x and y natin. Yung mga parameters natin, guys, b1, b2, b3 should also be linear. Okay? So hindi pwede kunyari 3 to the b1. Okay, e to the b2, hindi pwedeng ganon, no? So we cannot use ordinary least squares kapag if our parameters are not linear, no? So that's very important. That's your requirement number 2. Okay, how about number 3? Okay, once we have modeled, guys, once we have come up with a model, it does not stop there. Siguro nung did you do, may I ask the class, guys, if in your either SOE or COS subjects, did you do regression diagnostics? Paki-chat naman, please. Nag-regression diagnostics ba kayo? Kindly chat, please. Or unmute yourself. Or never heard yun, yung regression diagnostics. Okay, thank you. Thank you. Good. Good. Okay. Thank you so much. Ano ibig sabihin ng regression diagnostics, guys? Okay, now it doesn't mean that once we have come up with an output with a model that establishes the relationship between your dependent variable and your independent variable, then tapos na. Interpret na lang natin kung ano yung B1, B2, B3, kung ano yung mga parameters, then we're done. Okay, not so fast, guys. No? Not so fast. Remember, guys, yung ano natin, yung model natin is based on certain assumptions. So we have to check the validity of our model by doing what we call diagnostics. Kailangan mag-diagnostics tayo. Ibig sabihin, i-check natin kung valid yung model natin. And we call this regression diagnostics. Okay, some of the diagnostics that we need to do is, number one, to check your residuals, the variance of the residuals. Ang ginagawa natin dyan, guys, makukuha natin yung mga residuals. Ano ibig sabihin ng residuals? Yung difference between your actual value and your model value, your predicted value, your forecast value. Diba kasi kung may model tayo, ito yung model natin, di ba? Ito yung model natin. Then, if we substitute the parameters B0 plus B1 times the corresponding value of X1, B2 times X2 plus B3 times X3, then we will be able to come up with your predicted Y value, right? Predicted Y. No? Okay. So yung predicted Y value natin, i-compare natin dun sa actual Y. Diba kasi may mga ano tayo, may mga observations, no? Meron tayong mga yung data natin. Yung sa data natin, may exact, may ano yan, may value ng Y, may value ng X1, X2, X3. If we're going to use the model to predict Y, so we will have to substitute yung B1, B2, B3 natin and substitute X1, X2, X3 natin. We'll be able to come up with your Y value, and then we will compare your Y value with your actual Y value. So yung Y predicted minus Y actual, that will be your residual. Okay? So ang gagawin natin, ipa-plot natin yung residuals. Okay? Tapos, dapat guys, yung residuals, dapat constant yan. Okay? So we can plot the residuals or the residual squared. Okay? To check yung variance niya. Okay, dapat constant yung variance. Pag pinat natin, dapat wala siyang trend, hindi siya pataas, o hindi siya pababa, o hindi siya nagpa-fan out. No? When you say fan out, okay, ano ibig sabihin ng fan out? Anotate lang ako dito. Okay, pag sinabing fan out, guys, ganyan. Pag pinat natin yung residuals, parang gumaganyan. No? Okay, kunyari, ito yung mga residuals natin. Yan. Okay? So, it's fanning out or fan in, no? Papasok naman. So, pag ganito yung plot na residuals natin, guys, okay? So, we are violating the assumption that the requirement that your model should be constant in variance. Ang tawag sa issue na to, guys, ang tawag dito ay heteroskedasticity. No? Heteroskedasticity. Dapat yung residuals natin homoskedastic. How does that look like? Okay. Tanggalin ko na muna to. Wait, oops. Clear. Okay. Ano yung homoskedastic, guys? Pag homoskedastic, the error terms. So if we plot it, guys, then tingnan nyo, no? Yan. Diba? Random siya na, okay, it's not going up, it's not going down, it's not fanning out. So this is what we call homoskedastic. Okay, homoskedastic yung variance natin. And this is what we want. Kasi guys, kung yung ano natin, yung residuals natin, tumataas na ganun, let's assume it's going up like that, so may trend siya na ganun. Ibig sabihin nun, our model was not able to capture this movement. Okay? So kailangan, very important na assumption is this one. Homogeneity of the residual variance. Ibig sabihin nun, homogeneous siya or homoscedastic, ibig sabihin nun, equally spread yung residuals natin. Okay. Second, guys. Second, explanatory variables are not collinear. So this is only true if we're doing multiple linear regression tayo. Pag MLR, multiple linear regression, okay, kailangan i-check natin yung multi-collinearity. Obviously, guys, pag simple linear regression lang, wala namang ibang regressor, di ba? Wala namang ibang predictor, iisa lang. So there's no chance for your independent variable to be correlated with another independent variable. This condition number 4 is a condition for multiple linear regression. Dapat yung mga independent variables natin, they should not be correlated. Okay? Ito muna. Okay. So what do we mean by that? Going back here, guys, sa model natin. Ito. Okay, this one. Okay, dapat yung mga x1, x2, x3 natin, okay, they should not be correlated. We want our independent variables to be correlated with y. Yun ang gusto natin, no? Gusto natin na si x1 is correlated with y. Gusto natin si x2 correlated with y. Gusto natin si x3 correlated with y. We want that, no? Kasi they will be able to explain si y if they're highly correlated. But we don't want x1 to be correlated with x2. We don't want that, no? And x2 to be correlated with x3, etc. Okay, pag masyadong mataas yung correlation nila, then our model will suffer from what we call multi-collinearity. No? Magkakaproblema tayo pag multi-collinear yung ano natin, yung may multi-collinearity sa ano natin, sa model natin. Bakit kaya magkakaproblema pag ganun? We will have a problem with that, guys, kasi mahirap na malaman kung ano yung impact, how best is x1 explaining y, and how best is x2 explaining y. Kasi kung correlated sila, parang mag-aagawa na sila sa pag-explain kay y. And we don't want that to happen, no? Okay, we don't want that to happen. We want our independent variables to be not correlated to each other. Okay, so that's what we mean by explanatory variables are not collinear. Okay? Number 5, residuals, parang yung kanina, are independent from each other. Ano ibig sabihin ng independent? Yung residual at one point, okay, again, gawin natin. Okay. We don't want the residuals, kunyari itong residual na to, we don't want this to be correlated with this. We don't want this one to be correlated with this one. Okay, ayaw natin na correlated sila. Gusto natin independent sila. Now, this only happens, guys, this happens more. This is not a problem so much with cross-sectional data. Okay, hindi siya masyadong problem. Okay, bakit kaya, guys? Okay, if you recall, ano ibig sabihin ng cross-sectional data? Anyone, please? Can you recall what's the difference between a cross-sectional data and a time series data? Review natin. Anyone? Okay, let me refresh your memory a bit, guys. Di ba pag cross-sectional yung data, we're looking at several units of measures. Kunyari, the unit of measure can be countries, no? Or it can be individuals, or it can be schools. So you're looking at several units of measure. Kunyari, countries, kunyari ASEAN, Philippines, Malaysia, etc., etc. And then you're measuring certain variables of interest, GDP, GNP, employment rate, exchange rate, etc. So these are the variables of interest that you're measuring for these different units. No? And the unit, the measure is taken at one point in time. Kunyari, 2021 lang, 2021. GDP, GNP, mortality rate, birth rate, etc., etc. Taken across different countries. Kunyari, lahat, all over the world, no? Okay. Yeah, ito may answer si Naoki. Looks into several variables in the same point in time. Okay, not variables kasi ang ano din ang okay, so let me just clarify that. Thank you Naoki, no? Ang asan na yun? Asan yung chat ko? Okay, ang sabi ni Naoki, several variables in the same point in time. Yung variables, it can be several variables, can be cross-sectional, it can be time series. So ang tinitingnan natin sa cross-sectional data, several units of measures, no? Several units. Okay? So pwede siya maraming variables, but it's the time series ganun din. So sa time series naman, one individual unit, okay, isa lang, pero taken at different time frames over a period of time. Okay, so kunyari, same example, GNP, GDP, mortality rate, etc. So ano yun ha? Maraming variables yun. Pero you're just looking at the Philippines. Pero yung time component from 1970 to 2020, that's a time series. Okay? So maraming variables pa rin, pero iisang unit of measure. Yung unit of measure natin yung Philippines lang. And yung time frame natin, different time frames from 1970 up to 2020. That's a time series. Cross-sectional series, guys, several units of measure, Philippines, Indonesia, Thailand, etc. Time frame 1, 2020. Variables, several. So pwedeng several variables. Okay? And then lastly, yung panel data natin, it's a combination of a cross-sectional and a time series. Units of measure, marami, ASEAN 6. Philippines, Indonesia, Thailand, Vietnam, Singapore, and Indonesia. No? Tapos time frame, several, 1970 up to 2020. Variables, marami, GDP, GNP, etc., etc. Okay, so that's what we call a panel data. Okay, so I hope clear guys yung difference. Pause muna ako. Paki-chat naman please kung clear yung difference. Importante sa atin to guys. If we're able to distinguish between a cross-sectional data, a time series data, and a panel data. Paki-chat please kung clear yung ano natin. Clear so far yung kindly chat please. I'd like to know kung clear sa inyo. Okay, good. Thank you. Thank you all. Thank you. All right. So let me clear all here. Okay. So back here, guys, yung independence ng residual error terms. Hindi siya relevant for a cross-sectional data. Bakit? Bakit siya hindi siya relevant for a cross-sectional data? Kasi guys, ang cross-sectional data, 'di ba? Maraming units of measure. Tapos one point in time lang, 2020. Pwede nating ayusin, i-randomize yung arrangement ng data. Kunyari, kung alphabetical siya, kunyari, ang units natin, all the nations all over the world, alphabetical siya ang pag-ayos. Okay. Pag binago natin yung ayos yan, re-randomize natin, mababago na yung residuals natin, mababago na yung arrangement. Diba? Kasi kanina ang arrangement ng residuals, alphabetical. Okay, so pwedeng may makita tayong correlation among the residuals pag ganun yung ayos. Pero kung ibahin natin yung ayos, ginawa natin random na siya, hindi na alphabetical, so magbabago na yung ayos ng residuals natin. Okay, therefore guys, itong number 5 na to, yung independence of residual error terms, ibig sabihin hindi related si residual 1 kay residual 2 kay residual 3, etc. It's of no consequence kasi pwede natin baguhin yung order ng cross-sectional data. But that's not true, guys, for a time series data. Kasi pag time series data, may chronology yun di ba? May logic yung pagkakasunod-sunod niya. Okay, so from 1970 hanggang 2020, hindi natin pwedeng i-jumble yan. So the residuals, when we plot it, it's fixed. We cannot plot first 2020, tapos 1982, tapos 1990, hindi pa pwede yun. So ito guys, yung independence of residual terms, this is more for a time series. Okay, as compared to a cross-sectional data. Okay, I hope that's clear guys. And lastly ngayon, dapat yung residuals natin normally distributed. Okay, when you plot the residuals, dapat normally distributed siya. Okay, so all of this guys we're going to consider in this part of our lecture. And then after this guys, yung statistical test natin, babalikan din natin si t-test, si ANOVA, using R. Okay, so that's the difference between what you discussed before. Okay, all right. So next guys, paki-install natin. I'm sure hindi nyo pa na-install si OLS, RR, si Stargazer, PayStats. I think Psych and PayStats we have used this before, but yung OLS, RR, at saka Stargazer. So kindly install these packages. Now since nag-update ako ng ano, baka wala pa tong ano. So install ko na rin. I'll give you a few seconds guys to install and then to require. Okay. And then once you have installed it, guys, once you have installed it, let's require it. Lima yun na. Site base text. Okay. Dito na ako pupunta. Oops, ba yata nagbigay ko sa inyo? Parang kulang yata nalagay. Guys, although alam kong na ano natin scheme R, no? Na-load na natin dati. Kindly include also scheme R. I'm sorry about that. Parang iba yata yung nabigay yung files. Anyway. Okay. Paki-library, please. Require natin mga packages. As I said, guys, I'm using another file. Okay, kasi yung file na binigay ko sa inyo, some of it are blank because I want you to be writing the code yourself. Ba't nag-run na yun? Okay. So, let me pause for a while. Paki-chat naman please kung na-download na yung ano, na-require na yung mga packages natin. Kindly insert na lang si scheme R. Subukan nyo sa library kasi we used that before already. Si scheme R. Okay, thank you. Thank you, Angel. Thank you, Mark. Thank you, Sid. Okay, so let's wait for your classmates. If you're done, guys, kindly, yan, salamat, no? Okay, if you're done, guys, kindly import the wage data, the one that I gave you also. Import natin. Let's import here. Import data set. This is a CSV data set. Okay. Mm-hmm. Wage. Okay. Okay. Wage data set. May heading siya, wage, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. Okay, so ito siya. Okay, import. Once you have imported it, guys, kindly chat. Okay, great, great. Thank you. Thank you so much, guys, for your participation. Okay, I really appreciate you. Let's wait a few more seconds for the others. Yes, salamat. Salamat. You need to import the data set, guys, kasi yan ang gagamitin natin. Okay, thank you. Thank you, everyone. I hope the others are able to follow. Okay, let's quickly take a look at our data. So this is our data. Ang mga variables natin, education. Education refers to the number of years, okay, a person spent studying. Experience, number of years of experience. See here, 2, 22, may 44 na. Okay. Tenure, okay, number of years din to sa office. Experience yata is number of years working. Tenure, number of years in that office. Okay, so we have race, we have white, at saka may ng mga non-white. Gender, female, male. Civil status, single or married. Number of dependents, ilan yung mga anak nila. Okay, and then hourly wage. So this is actual data, US data to, guys. US data, and I think 1970 data to, no? So yung wage nila per hour, $3.10, isa 11.25, okay, 6, etc. May 22 dito, no? 22. Okay, so our objective is to determine, okay, kung ano yung effect, ano yung association, ano yung relationship ng hourly wage. This will be our dependent variable on the following variables: education, experience, tenure, race, gender, civil status, number of dependents. Okay, just as an aside, guys, kunyari ito yung research paper natin. Ano magiging statement of hypothesis natin? Let's start with HO1 kunyari. HO1. What do you think will be our null hypothesis, guys? We're trying to create a multiple linear regression. Multiple to, no? Kasi we have several independent variables. Okay, and take note, guys, some of your independent variables are continuous, okay? Quantitative siya, education, experience, tenure, and some are factors. Categorical siya. White, gender, single, Okay, yung number of dependents continues then. So you have 4 independent variables that are continuous and 3 independent variables that are factors. Okay? So, kunyari paper nyo to, no? Tapos isang part sa paper nyo, kailangan ilagay nyo kung ano yung mga null hypothesis nyo. How will our null hypothesis look like, guys? Once we have defined that hourly wages are dependent variable and the rest are independent variables. Anyone, please? Pwede unmute o pwede i-chat. Anyone? Okay, sige, baka nakalimutan nyo lang, no? Pero ang null hypothesis natin dito, dito may answer din natin. Ayan, si Naoki. Okay. So, okay. Thank you, Naoki. Okay. So that's correct. Pero we have to be more specific, no? So sabi ni Naoki, there is no significant difference between IB and the DB. So we have to be more specific. Tama, hindi difference, dapat relationship. So dapat there is no significant relationship between hourly wage and education. No? Ayan. Yan. So that will be one of our null hypotheses. So ang alternative niyan, there is a significant relationship between hourly wage and education. So that's one. Tapos ang pangalawa naman, hourly wage with experience, hourly wage with tenure, etc. Okay, so yun ang magiging natin, null hypothesis. And the regression output will be able to answer that. Kung may significant relationship ba between hourly wage and education, tapos may significant relationship ba between hourly wage and experience, etc. So since you have 7 independent variables, then you will have, for that, 7 null and alternative hypotheses. Okay. All right. So import na natin yung let me just copy para next time hindi na ako copy ko na lang to, no? Control C, Control V, and I'm going to call it wage. Okay? Kasi yun din yung ng file name, automatic. Okay. All right. So this was my code chunk, R code in read.csv. Tapos kung saan ko in-import yung data. All right. Now, ito wala to sa inyo, no? So, pag regression, guys, dapat you have to understand the data, no? So, this is now descriptive statistics muna tayo. Hindi pa actually kompletong descriptive statistics. No? Understand the data first, guys, before plunging into the regression. So, na-view na natin. I can remove this. Okay, so ano yung names, guys? Names. Ano yung binibigay sa atin ng names? Control Enter. Okay, so the names, guys, will give us. Okay, so let me just copy this. Baka Control C, ilagay ko sa chat. You might wish, in case you want to copy the null hypothesis. Okay. I-delete ko na siya. Okay. Yung names function, guys, it tells us the variables, education, experience, tenure, etc. So, we know this, guys, yung 7 dito, ibig sabihin ito yung 7. No? So, there are 8 variables all in all. So, in-identify lang natin yung mga names muna. And we know, guys, that we can print either the first 10 or if you want, first 6. Ang default nito, yung head function, yung first 6 lang. Okay, let me just print this. Ba't siya ando doon? Overlap siya dito. Okay, let me do that again. Okay, so you know this guys, iba yung head o yung tail, alam din natin yan. Okay. Bakit dito siya nag-print sa taas? Okay. Yung wage, 1 to 10 guys, pareho lang ng wage. Itong head ng wage. Okay, and then we can look at the structure. I don't know why it's printing up here. Kulang ba ako dito? Bakit siya taas siya ng print? Okay, anyway, dito ko lang titinan sa console. Okay, so take a look at our data. There are 526 observations, 8 variables all in all. Okay, 3 or 4 of our variables are continuous, integer siya, while 3 are character. No? Okay, tapos si hourly wage, numeric. The others are integer or so integer walang decimal siya, no? Okay lang yan. Number of dependents, ganun din. Si race, si gender, si civil status, character siya. So that's what we get from the structure. And then just to check guys, class, yung class ni wage, education, let's see this, ang class niya, integer siya. On the other hand, ang class ni race is character. And then aside from the structure, we can go to the summary function. Yan. So this is our summary. So the summary function gives us for a continuous or quantitative variable, it gives us the yung mga 6-number summary, 5-number summary, including the mean. Okay, we have education, minimum is 0. Ibig sabihin may mga hindi nag-aral, meron namang 18 years ang invested in number of years of education. Experience, ang pinaka maliit is 1 year lang. Tapos yung isa naman, 51. Sa tenure naman, merong wala pang 1 taon sa company. Tapos merong 44 years na. Okay, yung mga categorical guys, ang mabibigay lang yan, yung bilang. No? Ilan sila? 526. And then you also have the number of dependents. Okay. So sa hourly wage, merong 53 centavos lang. Meron namang 24.98. Okay. So that's the summary of our data. And then we can move on to other descriptive statistics. I'm not sure why natatago yung mga result dito. Meron ba akong check guys siya? Baka may hindi ako na-close na ano. Tama naman. Is there something I'm missing here? Bakit? Ba't nagdalawa na to? Something's wrong with my Oh, hindi sumusunod yung ano. Ano nangyari sa ano ko sa dahil lang guys hindi gumagalaw yung ano eh. Yung code chunk parang it doesn't go with the code chunk itself. What's wrong with my R? If you notice guys, yun nyo, yung code chunk ko, no? Hindi siya dun sa code chunk mismo. Ayan, no? See this? This is weird. First time ko lang na-experience to. If I run this, for example, oh, nag-overlap yung ano. Nag-overlap yung okay, sige, anyway. Let me just leave with that. No? Okay, so let's go to other descriptive statistics. Let me just copy this. Dito ko na i-run sa ano sa console, nagkakaproblema yung script window ko. Okay. We have discussed this before, guys, no? So, alam natin, guys, na yung psych package has a very powerful describe function. No? Okay, so it's quite similar to the summary ng ano ng base R. Okay, kaso dito it gives us more more statistical data. Okay, let me run that again. Yan. So describe, no? Yung variable 1 to 8, yung bilang niya, mean, standard deviation. Okay, of course, guys, itong mga character variables, walang ano to, walang meaning tong ano, no? Yung numbers na to because they're character variables. So trimmed median, mean absolute deviation, mean max range, and then you have a measure of skewness and kurtosis and the standard error. Okay, so these are descriptive statistics. We'll not go there anymore, but in your group work, guys, you will have to discuss that kasama yung descriptive statistics. Okay, so we can also use this place text. Sorry guys, I have to run it here in my console kasi nagkakagulo tong ano ko, tong script window ko. Okay. Okay, ganun din tong ano, yung stat.describe can also give us ito yung mga descriptive statistics niya, no? Number ng value 526. Ilan yung null, ibig sabihin 0 yung laman. 0 ibig sabihin 0 yung value. Minimum, maximum, range, sum, kung may gamit man yan, no? Median, mean, okay, variance, standard deviation, and the coefficient of variation. So this already gives us, guys, yung ano, yung some descriptive statistics that are not that were not available in sa describe ng psych. Okay. Pause muna ako, guys. Are you following? Chat naman please kung nakakasunod. Okay, thank you. Are you having the same problem, guys, sa ano nyo, sa script window nyo? Sa akin lang siguro to. Yung run button natin, yung run button ko, hindi sumusunod dun sa ano, Hindi sumusunod siya dun sa code chunk mismo. I don't know what's the problem here. Hindi ko makita. Okay. Anyway, sige. So, other descriptive statistics. Itong Stargazer, guys. Okay, itong Stargazer, let's run this. Stargazer is a very powerful tool for putting your output in a table. Okay, run ko siya. Oops. Sandali. Na-load ko na ba to? Library. Okay. Na-load ko na. So let me run that again. Yan. Okay. Okay. So you can see here, guys, na you can use there are several packages in R that we can use that will generate a better looking, okay, a better looking output, whether it's a regression output or a descriptive stat output. Okay, so Stargazer is one of them. Just a minute, guys. Alright, so saan ba ako? Itong mahirap sa akin ngayon kasi kailangan i-copy ko yung no? Okay. Plot natin, guys. I think ang binigay ko lang sa inyo yung una, no? Education lang at saka hourly wage. Okay, so let's plot the first one. Okay. Education and hourly wage. Anong mali ko dito? Data is equal to wage. Bakit? Nangyari? Ay, sorry. Mali, guys. Okay. I did this on purpose pala, no? Okay, this is wrong. Okay, guys. Why will this not plot? Did you try to plot this? I think you know the answer here already. Why did this not plot? Anyone? Bakit hindi nag-plot ng una? No? Mag-error siya sa akin. Kasi guys, if you take a look, class, pag tingnan natin yung mga object natin dito. Okay. Yeah, thank you, Kezia. Okay. The explanation, sinabi ni Kezia, no? Hindi ma-recognize ni R itong education at saka hourly wage. If you take a look at our objects here, ang meron lang natin wage, no? Wage lang yung meron natin. Okay. Now, hindi niya nare-recognize kung ano yung kung ano yung education at saka yung hourly wage. So dapat, guys, what we have to do is, tanggalin natin to. We have to define that this is from the wage data. And then si hourly wage, ganun din. Wage. Okay. Now this one, R will be able to understand. Kasi ang sinasabi natin, doon sa wage data, hanapin si education na variable. Tapos ganoon din si si hourly wage. And then ipa-plot natin, okay, my title, scatter plot of education hourly wage. The first variable will be the one on your x-axis. The second will be your y-axis. And usually guys, ang nasa x yung independent variable natin, ang nasa y yung dependent variable natin. So let's plot this. Okay, then we have this. Okay. All right. So we have here a plot of your hourly wage on the y-axis and education on the x-axis. Okay, sabi natin guys sa regression, gusto natin na highly correlated yung dalawang variables natin. In this case, mukhang hindi siya masyadong correlated, wala tayong masyadong makitang yung pattern ng positive slope or negative slope. Okay? So, not so much, but okay. Nevertheless, we'll still use this in a while, depende kung saan tayo aabot ngayon. No? Okay. So, okay. Ito guys, ano lang na iba dito? Linagyan lang natin ng so kindly copy yung una guys, tapos i-modify nyo na lang. Linagyan lang natin ng label, yung x-axis, yung y label, hourly wage, and then plot character, di ba? If you recall guys, sa natin dati sa ggplot2, yung 19, these are the small dots. Okay, frame is equal to false, ibig sabihin wag lagyan ng box, and then main is equal to scatter plot. Okay, so very basic lang na na plot function. This is from base R, this is not from ggplot. Okay, ano nangyari sa akin? So plot, let's label. Tama naman. Okay, let me see sa plots. Okay, bakit ayaw niya mag-plot? Let me give this a name. Ako ng B1 minus and then B1. Okay, let's see. Binigyan ko siya ng pangalan tapos papaprint yung B1. Null. Bakit null? Saan ako nagkamali dito? Why? Okay, we're able to generate the plot, guys. Paki-chat naman please kung na-generate yung plot. I'm having problems with my R. So tama naman, ipa-plot sa x-axis, sa y-axis, may label yung x-axis, may label yung y-axis. Define natin yung plot character. Sinabi natin na tanggalin yung frame. Tapos may main title din, open, close. This is correct. Okay, feedback nga guys if you were able to plot. Okay, bakit kayo naka-plot? Para sa akin hindi naman. Okay. Anyway guys, naglolo ko tong R ko. But it's good that you're able to plot, no? So, ang kaiba lang naman yan guys, yung nagdagdag lang tayo ng no? And then for this one, yung last part dito, okay, it's the same. Same lang siya. Tapos, kasi how would you describe guys yung x-axis sa plot na to? May problema nga ako dito kasi dapat meron akong tick marks na hindi nasarado. Pero hindi ko makita. Dito ko nga muna ito. Hindi talaga eh. Anyway. Yung shaded dapat dito guys. Dapat nasa code chunk yan eh. Pero dito, okay. Sorry guys, nakaka-waste ako ng time nito. Okay. Anyway guys, ito dinagdag lang na yung axis natin, okay, 1 refers to x-axis, x-axis, and then yung sequence niya from 0 to 20, and then increments of 5. Kindly add this guys. I'm sorry I can't, my R is not working. And kindly tell me if nabago yung x-axis natin. Paki-chat naman please kung nabago yung x-axis natin. If we insert this, include natin yung axis. So this redefines your x-axis, 1 siya for x-axis. Kung y-axis 2, and then the sequence is from 0 to 20 increments of 5. Okay, so kindly, okay. Naoki, what happened? Can you please describe what happened to your plot? You can, if you may please, unmute yourself na lang.
Sir, humaba po yung x-axis. Nag-extend siya 15 to 20.
Okay, good. Kasi kanina, di ba, hindi, yung original, hindi umabot ng up to 20, di ba?
Yes
right?
po.
Okay, good. All right. So, initially guys, ang titingnan lang muna natin is simple regression lang muna tayo, no? Okay, so this is simple regression. So in simple regression, guys, there's a very powerful function in R. It's the LM, linear model function. Okay. Now we learned the attach function before. Naalala niyo yun, guys? Kindly chat please if you recall kung yes naaral natin tong attach function na to. Yes ba o no? Feedback, please, guys. I might have discussed this in the other class, but could you kindly please? Okay, hindi pa, no? All right, sige, okay. So let me discuss what this attach function is. Okay, so first, guys, without running the attach function, let's run this first. Correlation, Control C, correlation ng education and hourly wage. Di ba sabi natin, one way to test yung correlation coefficient ng dalawang variables, one way to test if they have a linear relationship is to use the correlation coefficient. So sa R, ang function is core. No? So here we would like to see ano yung ano. Huwag niyo muna i-run tong attach guys ha. Ano yung correlation ng education at saka hourly wage. If I run this, di ba? Nag-error siya. Bakit? Hindi nakikita yung education at saka hourly wage. Wala kasi tayong object na education at saka hourly wage dito. These are variables that can be found in the data wage. Okay. If you're going to just make use of one variable, one object, kunwari wage, okay, what you can do is attach this wage. Attach this data. Control C, Control V. I-attach natin yung data na to. What it does is that it signals to R na lahat ng mga variables na ginagamit natin nanggagaling yun sa sa wage na data, no? So that's why you don't have to redefine wage dollar education, wage dollar hourly wage, no? So if we attach this, attach natin, tapos i-run ulit natin yung correlation, control enter, yan. Nag-run na siya, no? 0.4. Okay? Nag-run na siya. Why was R able to recognize itong education at saka hourly wage? Kasi nga in-attach natin yung yung data set, yung data frame where it came from. Okay? All right? Clear so far, guys? Okay, ito. How about this? Control C, Control V. Correlation. Okay. Paano to? Bakit nag-error? Bakit nag-error, guys? Nag-error siya kasi dun sa wage data set natin, di ba? Sa wage natin, merong mga factors, no? May mga factors. So yung race, gender, and civil status. And you don't have correlation. Hindi pa pwede magka-correlation si education at saka si race, si experience at saka si gender, etc. So what we're going to do is we're just going to get the correlation among education, experience, and tenure. Tatanggalin natin itong race, gender, civil status. Okay, sandali, 1 minute. Sorry, I answered the knock on the door. Okay, so where were we? Nag-error tayo kasi guys, meron tayong mga categorical variables dito. So if we want to get the correlation among the variables here, tanggalin natin tong si race, gender, and civil status. So how do we do that? Okay, we can use this, no? Ito. Control C, Control V. So how do we do this? We're getting the correlation of wage. Tapos remember, pwede natin i-subset, di ba yung brackets na to? Naka-subset siya. Lahat ng rows kasama, yung unang space dito, then comma, and then negative C, 4 to 6. Ibig sabihin nun, tatanggalin si 4 to 6, negative. List 4 to 6. So that's the same as C, 1, 2, 3, 7, 8. 1 up to 3, then 7, 8. Pareho lang yon. Or tinagal natin si 4 to 6. Okay, so let's run this. There. We can now see the correlation. Yeah. Let me see kung pwede ito, no? Lagyan ko ng round dito. Round, let's see, round. Round natin to 3 decimal places. Let's see. Okay, there. Okay, mas maganda yung pagka-present dito. Of course, guys, yung correlation ng variable with itself should be 1. So yung diagonal natin 1, no? Okay, and then you can see here education, correlation experience at saka education is negative 0.3. Ang ibig sabihin ng negative, it's a negative dyan, ibig sabihin negative correlation. When one value increases, the other one decreases. No? Ibig sabihin ng negative. Okay. Now, if you take a look at the others, tingnan natin si hourly wage. So si hourly wage, ang correlation niya with education, experience, tenure, ito, no? 0.406, 0.113, 0.347, and negative 0.054. Of all the independent variables, ang pinaka-strong na correlation with hourly wage is education, 0.4 siya. Okay? So this can be a signal that the best predictor for hourly wage would be education. Kung simple linear regression lang, kung pipili lang tayo ng isa, no? Isang variable ang gagamitin natin to explain hourly wage, then pinakamaganda si education. Okay? But we're not only doing simple regression, we're also going to do multiple linear regression. Okay, tapos guys, take note also that we don't want your variables, your independent variables, to be highly correlated with others. So si experience kunyari, o si education. Okay? Negative 0.3, negative 0.05, negative 0.215. Okay, mukhang maliliit naman correlation nila. No? Not so much, not so big a correlation. Ito lang yung isa, experience and tenure. 0.499. Medyo nasa middle na correlation siya. No? Medium yung correlation. But the rest, I don't see any problem. Wala yung mga correlation na 0.6, 0.7. No? So mukhang okay naman. No? But anyway, we'll see when we do our regression. Okay, so it's almost time, guys. So let me just start with this one. No? Ito. At least makapagsimula tayo ng isang regression. So when you do regression, guys, sa R, we use this. Control C. Okay. Tanggalin ko muna yung parenthesis, no? So what am I doing here? I'm creating a model, mod 1, and I'm using the LM function. LM stands for linear model. And then this one is our dependent variable, hourly wage. And then tilde, ito yung tilde yung nasa nasa taas ng tick symbol, no? Ng grave accent. And then data is equal to wage. So this is how we run a regression model. Run natin. So nagkaroon na tayo ng mod 1 dito, no? Oo, oo. Time na. You may go, guys, ha? I'm just extending this up to this last one. Okay, guys, you feel free to go, guys. Tinatapos ko lang tong isa na to. Okay, so sinabi ko nga kanina, pa-extend lang ng konti. But you may go, guys, you may go. And then yung summary, no? Ito yung summary na to. Okay, so we have here the output for the model 1. Okay, so we're going to look at this later on. Ito yung nakikita niyong output sa statistika, sa SAS, sa stata. Okay, so you have here the coefficients, the p-value. Okay, so there are other things that you can find in the mod 1. So next meeting, guys, we'll continue with this. Titingnan natin yung aaralin natin to kung ano ba laman itong mod 1 na to. Okay. Lastly, if I get the names ng mod 1. Okay. So ito yung laman ng object natin ng model 1. Okay, and then we're going to look at this next meeting. Okay, so let me stop recording.